We are losing the night. Natural darkness and the stars are being overwhelmed by artificial light.
The artificial light that we're pumping out every night across whole continents is so powerful.
The majority of people in North America and Europe have never seen the Milky Way.
Light pollution is clearly bad news for stargazers, but what's alarming scientists is the growing evidence of its contribution to biodiversity loss.
Pioneering experiments around the world, like this one north of Berlin, are showing how artificial light's influence extends far deeper than previously thought, even into the water.
We are here at Lake Stechlin, which is one of the deepest and clearest lakes in northern Germany.
It's also a sprawling outdoor laboratory, where one study is focusing on zooplankton, microscopic creatures that are key to supporting life on Earth.
These might be small things, but that is the most important biomass of, the amount of organisms around the world.
They eat algae and they are being eaten by fish, so they are a very critical component of the aquatic food web.
Scientists working here have co-developed a high-resolution camera and AI computer program.
So I'm putting the camera down, let's see.
The system is revealing new detail about the nightly migration of these creatures.
Very simply, during the day the zooplankton has to hide at lower depth to not be seen by visual predators, and at night they come up to the surface to forage on algae, on phytoplankton.
Deployed under illuminated bridges in Berlin, the camera showed that zooplankton stayed at lower depths, suggesting that artificial light can interrupt their feeding cycle.
Now, when we put light on these systems, they might never have time to go eat because it's always light and they're always afraid of getting eaten by the fish. That's why we have to investigate that.
If light pollution stops them feeding, any decline could cause a collapse of fish populations further up the food chain. But other creatures are also being affected. And it's not just the amount, but also the type of light pollution that's disrupting nature. LED technology has made lighting cheaper and more energy efficient, but it's also turned outdoor lighting more blue. Visual ecologists at the UK's Exeter University have computer modelled the way some insects see the world. And from that point of view, blue light in particular is blinding, blurring natural rhythms of day and night.
So the problem is not LEDs per se. What we've done is use LEDs to produce white lights. What that does is introduce a lot more blue wavelengths into the environment. And many of these biological processes are very sensitive to the blue emissions.
The effect on pollinating moths is a particular concern. Often overlooked in favour of bees, populations of these key fertilisers of crops and other plants are in critical decline.
Much of the food we eat depends on a pollinator coming, moving pollen between flowers, and moths in particular. Their long tongues allow them to get into some flowers more easily than other insects. Also, moths fly long distances, and in an increasingly fragmented habitat, where the patches of wildflowers might be further and further apart from one another, maintaining these long distance links between flower populations can only be done by insects that can fly long distances.
In fields around Exeter University's Cornwall campus, experimental chambers and traps are set to see how captives react to different light in the real world.
Well, most of our moths are nocturnal, so light pollution is going to hugely change the way that they see the world. So they've evolved to behave under conditions like moonlight and starlight, and the spectra of the different lights that we're showing them are completely different.
One experiment is designed to see how different coloured lights might warp a moth's perception of camouflage. Another is testing an extraordinary computer model prediction that lower levels of one particular light can make certain flowers suddenly invisible to moths. The project has some way to go before results are published, but there's also a common practical goal.
We can create lots of different types of artificial light, street lights, for example, that give off different wavelengths. So our hope is that we can find types of light, types of spectra, wavelengths, that do less harm to the environment.
Back in Germany, in the countryside west of Berlin, trials of new street lighting, specifically tuned and directed not to attract flying insects, have produced stunning results.
It's huge. It's actually even better than we thought. We said we want to reduce the vacuum cleaner effect, so the attraction towards the light source. And it's actually really what happens.
Dramatic insect declines have been reported in Germany. Many factors like habitat loss and agricultural pesticides have been blamed. But for vulnerable aquatic insects like mayflies, light pollution is a known threat.
The mate finding is interrupted because the males, they are trapped near the light sources. But the other problem is that females, when they lay their eggs, they are distracted by lit roads. They get confused and no more mayflies if the eggs are not laid into water.
Now, trials are underway to test the new lights on footpaths and roads in 4 towns across Germany. For their Berlin-based manufacturer, the science has inspired a new range of commercial fittings, specifically designed to cut emissions of polluting light.
We really learned exactly how to work with lighting curves, with distances, color temperatures, light cutoff, to really achieve an acceptable level, to be in harmony with nature.
Everyone concerned about the health of Earth's delicate web of life hopes that society will recognize the need to halt the growing disruptive influence of artificial light.